friends, it's time for another Friday Fun Fact, where I'll give you a little bit of information that you might not have known before. July 20th was Moon Day, so let's take a giant leap into some moon facts. The moon is our only satellite. Kinda lame compared to some other planets in our solar system. I'm looking at you, Jupiter, you gotta calm down, you have more than 60 now. Most of us know the moon basics. It's the nearest thing to Earth, between 230 and 250,000 miles away. It's tidally locked with us, meaning 1 day and 1 year on the moon are the same, and we went there once. But, how did it get there? The moon's not recent. It's been a familiar face as long as humans have been studying the night sky, so it's not like we saw its birth, so to speak. And the fact that it's covered in pockmarks means it's really old, since the whole asteroid bombardment phase ended quite a while ago. This means that the whole "how'd that huge floating rock get there?" question has been here a long time as well. There are dozens of myths about what the moon is and what it's for, but today we'll be talking straight up science. Early scientific origin theories can be divided into 3 categories. Co-accretion, or the idea that the moon and the Earth formed at the same time from the same stuff. Fission, the idea that at one point the proto-Earth spun so fast some of it was flung into space. And capture, that the moon was formed somewhere else and Earth's gravitational field yoinked it into orbit. All of these, as I am sure you have assumed, are incorrect. There's way too much angular momentum for the Earth and Moon to have been formed simultaneously. The proto-Earth couldn't have gotten to the point on its own where it could eject the right stuff to make the moon. And finally, it would be really hard to break something moon-sized into the orbit it has without crashing into the Earth. By the 1950s, we'd gotten better at the moon science and realized that the moon is way less dense than we are, probably because it doesn't have nearly as much iron. This kind of put the kibosh on the common origin idea, but we didn't really find a new model until the 80s, when the giant impact hypothesis gained support. The idea here was shortly after the proto-Earth formed, it was struck by something roughly the size of Mars. But here's the important bit. Sure, proto-Earth was probably still a little soupy, but it and its aggressor had both split the core and the mantle, meaning all the super heavy stuff had sunk into the middle. So, when tons of material from the crash was ejected into space, it was mostly super hot mantle material. This is why the moon doesn't have the same things Earth does. The debris cloud eventually coalesced into the proto-moon, which then underwent a long period of bombardment and volcanic activity, cooling into the craters and valleys that we know today. I've gotta say, it's pretty cool to look up at night and know that I'm looking at the remnants of a planetary smackdown. I used the entry on our moon from the Encyclopedia Britannica for this fun fact, and it is where I will refer you now, as today is the last Friday Fun Fact. If you're curious and want to know more, you can explore the Encyclopedia Britannica for free with your library card, or come into the library and check out any of these books. They're all in our library system. Live long and prosper, my friends, and thanks for watching.